All right, let's try this again. Okay, so I just realized I should have been using centimeters, not meters this whole time. I was not paying any attention. All right, so I just put a little note for the old videos, but you get the idea. You can just change the units, okay? I'm not remaking them. All right, so let's take a look at this. So I should have maybe left a column here for position, okay? So the positions here, 0, I think I had, let me see where mine is, 1.3, 5, 10.7, 18.1. Okay, whatever. Okay, so these were my possessions, obviously in centimeters. I didn't catch that. All right, so what we want to do now is we want to try to think about the average velocity in each time interval, right? Because we already know that the puck is getting faster. All right, so in this interval here, right, it goes from 0 to 1.3 centimeters. So this is going to be 1.3 centimeters. And that took 1.1 seconds. So that means on average, the velocity in that interval is 13 centimeters per second. Okay. But again, we're talking about a 0.1 second interval, and that's not really telling us instantaneously how fast it's going, which is what we need to make a velocity graph. Okay. So obviously at the beginning, it's not even moving at all. Okay. So by the end, at that 0.1 second mark, if the average is 13, it's going to have to be going much faster at the end, right? It has to go faster at the end here to average out with the 0 at the beginning, so that for that interval, the average is 13, okay? And this kind of brings up a new equation that we can use, which is the average velocity is the initial plus the final divided by 2, just like a simple average. All right, so if this is 0, 13 centimeters per second would be the average. At 0.1 seconds, the velocity would be 26, double that, okay? Because it's continuously getting faster throughout that interval, all right? The easiest way to make this graph is just to use this average velocity, but then we want to think about the time where the average is the instantaneous, okay? So if it's continuously gaining speed, as the clock runs, right, this average velocity is going to happen at the middle time interval, or at the middle time clock reading, okay? So between 0 seconds and 0.1 seconds, at 0.05 seconds, that's where this velocity is also the instantaneous velocity. It's at the middle time interval, okay? All right, so for the second one, it's going to go from 5 to 1.3 to 5. So this is going to be 3.7, okay, centimeters in that interval. It still takes 0.1 seconds because now we're talking about the next interval, okay? So the average velocity here is going to be 37 centimeters per second, okay, on average between those points, all right? So again, this is going to happen at the middle of that time interval, which is going to be now 0.15 seconds. Okay, and then you could go through and average this, and you can find out the instantaneous velocity at the tenths. I mean, you could do it that way. It's just a little harder work. Okay, but basically here, the big idea is that the clock time, when the average velocity is also the instantaneous velocity, happens at the middle time point of that interval. Okay, that's very important. The middle time point of that interval is where it happens. Okay, so these are the numbers you're going to get. Divide by 0.1, get these velocities at the middle time interval. Okay, and then the next thing you're going to do is go back to pivot, centimeters per second now. Okay, and you're going to make a graph now with new times and new velocities. Okay, you just need to make a new column. All right, I think you can figure that out. All right, so there you go.